In our Data Masterclass, data leaders share their unique stories. We are thrilled to welcome Detlef Nauck, the head of AI and data science research at the British Telecom Group. Our discussion focuses on the risks and opportunities of leveraging generative AI within a corporate environment. Let us welcome your host, Alex Borek.
Hello, data and AI leaders. I have a huge pleasure in this Data Masterclass podcast to welcome Detlef Nauck, who is a distinguished engineer and the head of AI and data science research at British Telecom, BT, in the UK. And he is also a visiting professor at Bournemouth University. And we will talk today about the very, very exciting topic that you hear all day, which is generative AI. Before we get into that, tell us a bit about your background. Why do you think you can speak about a topic so well? And
hi, Alex. Thanks for having me. As you said, I work at BT. I run the AI and data science research program. And generative AI is currently a big topic for us. We're looking into that space for a number of years already. We have always looked at large language models to see if we can make use of them for conversational interfaces, customer service, and we always found that they're prone to making stuff up and hallucinations, as they call it, and they're also quite large, unwieldy, and expensive to run. So the research in my program on large language models has always looked at, can we make them small enough so that we can actually use them, and can we train them with our own internal data so they kind of know what they're talking about. And this work has been going on for a couple of years, but now we have been surprised by the release of ChatGPT and the kind of capabilities that these models seem to have. And now there's a massive hype around this. Everybody wants to try them. So we're now slightly pivoting for a bit. We're doing some use cases and have a look. What is the value of these systems? Can you actually run them in an organization? And how do you constrain them so that you actually get some value out of it?
And I saw also that you had a number of publications and patents in general in that AI area, and also in natural language. Is that right?
Not natural language. No, my patents are around typically machine learning, and typically machine learning in networks, and that's just a quirk of the patenting law. If you want to have a patent, it has to have a physical embodiment. So you can't patent an algorithm or a process. It has to be something that is essentially that you can touch, you could say it this way. And so my work has always been in machine learning. And so I looked into using machine learning algorithms to control networks. And because this is the space where you can actually do patents.
Nice. So what is the patent that you're most proud of, where you say this is really cool?
Probably one around energy management in networks, how to selectively switch off network elements to save energy.
Oh, that is very useful, in particular when you want to become more sustainable.
Yeah, exactly.
And energy prices are up, so.
Yeah, that was a good one to do.
Great. And could you maybe describe for those, I mean, British Telecom probably is something that is known around the world, in particular the red telephone cells. I think that don't exist anymore, but I think they are still iconic. But can you tell us a bit about your company and the business models you're in?
Yeah. So BT, or British Telecommunications PLC, is the incumbent telco in the United Kingdom. We have around 100,000 people working for the company. We operate worldwide. In the UK, we do the typical play around landline, mobile, broadband, and television. And then internationally, we do networks for large organizations, essentially. The the business is split into consumer business and enterprise. And then we have in the business we call OpenReach, which is the local network in the UK, manages that. It's obviously a regulated business, so the part that owns the local network has to treat all telecommunication providers equally. So this is OpenReach is part of the group, but a separate business. And then we have two internal parts, one that looks after the network, and the other one is called digital, which looks after the data and systems. And this is also where all the AI happens. And my research team sits in digital now.
How does data and AI help you to achieve value in your organization? Why do you have these groups? I mean, it seems like you have for a research group that's quite a size, and then you have a larger organization around that to bring that into production and to create things that are products, you could say. So what makes you invest?
Well, data has always been really important for the company, right? So we need data to manage our network. The network produces huge amounts of data every second. So all the telemetry that comes out of it, we needed to understand what's the status of the network, what sort of faults are in the network. We need to be able to detect them as early as possible, ideally predict them and preempt them. But then we run obviously a large number of internal processes for our customers. And this means we have a lot of data in that space too. We use what any kind of service industry would use data for marketing, for churn prevention. We do data analysis around the effectiveness of our processes. It's data everywhere. And the business has decided to do as much with AI as possible. And again, this is around finding out if something in a process or in a service or in the network goes wrong as quickly as possible, ideally in a predictive way. So lots of anomaly detection happens. We have a large mobile workforce, over 30,000 engineers. All the plans for the workforce, all the schedules for the workforce are all managed by one large AI system, which is kind of good old-fashioned AI, is optimization and search. And that we have for almost 20 years. It's something that we built ourselves.
Wow, so it seems like you have already a legacy of AI. I mean, legacy not necessarily in depth, but more in terms of history.
Yeah, BT has always worked in AI. When I joined the company in 1999, there was already an AI group established, and I started to do data science. So basically, it was called data analytics back then when I joined, and this has grown and grown over time. In the UK, BT is actually the company with the largest AI patent portfolio, which is probably surprising for most people.
Well, it reminds me a bit of Bell Labs. You know, one of my friends and mentors, Tom Redman, started his career at Bell Labs, and I think it sounds like it's a similar philosophy and approach.
It's comparable, yeah. We call it the BT Labs, but the research department has always been there. It was already there when before privatization, when it was still the post office.
Great. And so tell me, what's all the hype about? I mean, everyone is going crazy at the moment. Suddenly, like everyone, like literally everyone is talking about AI. Like people like you and me, we've been talking about AI for years and we've been dealing with that, but nobody understood really what we are doing. But now everyone wants to be part of it. Everyone wants to invest. Everyone wants to use it. Why?
Yeah. Well, it's clearly because of ChatGPT. It's over the last year, what we have seen is models that can generate images that came out last summer. So DALL-E or Stable Diffusion, Midjourney, these kind of companies. And that hasn't really triggered the imagination of the public. But when ChatGPT was released in November, end of November, that had enormous interest. And I saw some numbers that ChatGPT achieved 100 million users within 2 months. For TikTok, it took 9 months to get to 100 million users. So there's massive interest because it triggers the imagination. Suddenly you have a system that can talk with you, and it's much better than the Siris and intelligent assistants on your phone, right? It really seems to understand what you're asking it to do, and it comes up with very authoritative, long, well-written texts. So it's a complete game changer in sort of this kind of interface. And then you find out it can also write software, and
and hundreds of other different things that you find out on the
yeah,
side.
exactly.
Being a lawyer, better doctor, better many things than we, you know.
So, I mean, obviously, there's a bit of a reality check here. These underpinning models, deep networks, and have been around for roughly 15 years, not quite, maybe 12, 13. It started all with the ImageNet competition, so deep networks being able to recognize images and put the right label next to it. And then it went into facial image recognition, generation of deep fakes. Then we got the networks for language processing, first translation, now text generation. And then we get the combination of these diffusion networks, like using text to generate images or even video. So now we are in this age of generative AI that produces artifacts. And so it's not just text and images and video. We'll also get, and this is a bit hidden in this whole hype, is deep networks that find new solutions for problems. Like you've seen AlphaFold, which generates 3D structures of proteins. DeepMind has done AlphaTensor, which is a deep network trained through reinforcement learning that optimizes matrix multiplications. So the area of reinforcement learning in deep networks is something that's going to be even bigger than large language models, because these things you will be able to use to make new discoveries and to configure systems, find solutions. And that is going to be another game changer. But this is more than on the kind of enterprise side. These kind of large language models, they're going to change the way we interact with information. And so that has everybody interested.
Hooked. Yeah, I just want to say, you know, like we have machines solving problems better than humans in a lot of areas already over the last few years. We had many areas where machines were outcompeting humans. Yet nothing was so exciting to humans than communicating with a machine in natural language. Yeah. And I think it tells you maybe more about the human nature than about machine nature. Yes. Humans love to communicate. It's deeply integrated into who we are as beings, I think. And that's why it was so fascinating.
Yes.
Do you think that is also the explanation why it's such a hype now?
I think so, yeah. So if something talks back to you, you think it's a person, right? And so then this is immediately fascinating for us. And then everybody wants to get their hands on it and try it. And I mean, if I look across the internet, I think most people are trying to get ChatGPT to do something it's not supposed to do. But that seems to be the major drive
to be part of the fun.
But I mean, obviously there are opportunities and values to be had, but at the same time, we have to be careful because these systems are stochastic systems, so they are not always right. They make stuff up. They essentially have learned the statistics of language, and they're very good at stringing language together. They have read more text than a human could read in their lifetime, and that gives this kind of emergent capability of producing natural text and have this kind of impression that they can reason. But all of this is underpinned only from statistical analysis of text, if you like. What's missing is the understanding of concepts. They don't know what they're talking about, and they make stuff up. And so you see this in particular when let's say you ask for a specific number, or you ask for a reference, maybe to a website or to an article. These are the things where they get it wrong, because this is statistically not very frequent. It's a very precise piece of information is not statistically frequent. And so they haven't seen it a lot in the training data. and then they just filled something in, and that's still a problem to be fixed. One of the major things is it's going to change the way we deal with information. If you can go to a search engine and it returns a narrative instead of a list of web pages, people are very likely to just take the narrative and run with it. They're not going to fact check it because it sounds authoritative. And that's going to be an interesting development, how that will influence what people do.
Yeah, and I think that's also the impression that I got. You know, I'm using ChatGPT quite a lot for everything these days, really every day, for private things, for business things, because it's so powerful. But I also found that whenever you ask something that requires a bit of creativity, you know, something that has not been combined this way before, or not often combined this way before, the machine really struggles here. And I think that that's sort of probably, you know, and fills the gaps, or is not able to create. So even if you explain exactly what you want, it's not able to create that. And I think that's probably what you're describing. So it can do mainstream very well. That's my impression. And I think that is very valuable for a lot of domains where it is about mainstream communication, and you maybe just add a little bit of thing on top that is special. But I think for all the really truly creative tasks, I think it still struggles.
Yeah. I mean, because it doesn't understand concepts. So creativity typically means you take some concepts and arrange them in a new way that hasn't been there before. And so these systems can only they have learned from what's frequent in text. And I mean, there's a lot of stuff that's frequent in text, and so it's sometimes surprising. Especially when you ask it to do something for you in an area that you usually don't read about or talk about. You're surprised that this can be done, but this is then your perspective. You're not familiar with it, but still there's tons of stuff about it in the internet. And so it was in the training data. So for example, you read that ChatGPT, or at least with a new language model that underpins it, GPT-4, can pass the bar or it can pass medical kind of tests or exams. But all of these kind of exams, they are based on natural language, right? You have to write a narrative. And there are tons of examples on these things on the internet. So it's actually relatively simple for such a system to pass the exam. It's difficult for a person because you need to read so much and you need to memorize so much. But
there are so many already, there's so much material out there that you can just take in, because it's a frequent, very, very frequent thing that people discuss, and it's out there. While if you would do an exam that is very niche, the machine would struggle, although it might be a much easier exam for a human.
Yeah, I mean, it struggles more in programming exams and mathematical exams, where you don't find these particular examples, and because it can't reason with concepts, it finds these things more difficult. And but
yet we have 100 million users in such a short amount of time. So something must have happened here, because NLP is not new. Large language models are not new. What happened?
Yeah, I mean, it must be the kind of surprise that you have a system that can produce like long form text that is very authoritative and can actually answer meaningful questions, which you might struggle answering when you go into Google and use keywords. And
such technologies have been out there for the last few years. Why now? Why is it creating such a hype now?
I mean, people are used to talk to Alexa and Siri and these kind of systems, right? And they're used to them not understanding what you want and coming back with sorry, can't do, or doing something different. But here there's a system that doesn't seem to suffer from this sort of problem.
And it's brought to consumers at the same time, like it was opened up to consumers as well.
Yeah, exactly. It was immediately open to everybody.
Yeah.
And you can do trivial things with it. You can have fun with it, right? You can ask it, tell me a joke, or play knock jokes with it, and all sorts of stuff that you can't do with any of the existing computer systems.
But was there any particular progress from a science point of view here made?
It's the way they trained it, right? So the progress was the reinforcement type learning that they put on top of it. So the large language models are trained with sequences. That is the most costly part of the whole training. So GPT stands for Generalized Pre-trained Transformer. Transformer is what they call the network architecture, typically tens or hundreds of layers of neurons, and they're designed in a special kind of format, and so they can process these sequences, and then they're trained with sequences, which is essentially text. The text is embedded, which means you represent words as vectors, and the similarity of the vectors helps you to maintain context of text. And this training phase, where you have to churn terabytes of text through, takes longest and is most expensive. When you have that, then you have a system that can basically complete your sentences. You prompt it with a sentence and it starts spitting out text. Now you want to instruct it. So you want, instead of just having it complete text, you want to say, write me a particular text about a topic. And that needs to be trained in. So they had created tons of question-answer pairs or instructions and the appropriate response. And that was then trained on top, standard supervised learning. Then they had people trying it out. So they prompted it and did this several times, because it's a probabilistic system. You always get a different response. And then they took one question, generated 4 answers, for example, and they marked them. This is a good one, this is a bad one. So this is where you had human in the loop for the first time. And they used this data to train another network that learned a reward function. So basically, this network can decide if it sees a question and the response, is this a good response or a bad response? And this was then used in the next step to continually train the system, basically prompting it and looking at the response and giving feedback. And so this is called reinforcement learning with human feedback. And this is then what makes it extra expensive in terms of effort, right? You need hundreds of people to do this. And
so they really, I mean, the breakthrough was made by throwing money at the problem. Could you say that?
Yeah, exactly. It's
because they had more funds than others on that to solve that problem.
Yeah, exactly. So just the compute cost about $5 million. It's estimated for building ChatGPT. But then on top of this, you have to pay the people who do the feedback, who produce question-answer pairs initially, and then use this feedback mechanism to rank the quality. And this is also where the ethical questions then arise, because to make this possible, they use cheap labor. And so that's one of the things to keep an eye on in the future. How have these things been built, and what workforces have been used to train these systems?
And do you know if they used platforms like Mechanical Turk, like a crowdsourcing platform?
Yeah, something like this. It's probably not exactly that one, but I mean, if you look around, there are many of these platforms that offer data labeling, and they basically offer these services. They have cheap workforces all over the planet, and if you want to use one of these companies, make sure you pick an ethical one.
And now these days, maybe you don't know if it's really humans doing that effort. Yeah. Maybe somebody plugs in a generative AI.
One of the predictions, right? So now you generate content, and that goes back on the internet. So you basically ruin your data source for the next generation of AI models. So you won't be able to learn anything anymore, because you're training on inferior artificial content that has been mass produced and is out there. So there's a real worry around curating original data. And of course, now you have something like ChatGPT. You can use ChatGPT to generate your next kind of level of training data. And question is, will this make the system better or worse? But
Detlef, do these systems rank the authority of the sources somehow? What I'm thinking about, when you ask questions about management trends, I mean, obviously, something like Harvard Business Review or McKinsey Quarterly would be probably high authoritative source, while in medium.com, you never know.
Yeah.
Like some of them are the best articles in the world and some are not so good. So, or fluffy. Do you know if that's going into that ranking? And is that done automatically, or is that also like somehow done by somebody designing the machines? Automatically, I mean, like, is the neural network discovering these rankings just by reinforcement learning, or is that something where humans actually design the algorithmic architecture or some additional data that you feed the system?
Well, the only place where you could fit this in is this reinforcement learning stage. But
right.
What I've read about the training process, that was not a consideration. So there's no ranking of the quality of the information that went in. It's just text. The quality ranking then happens just through the feedback signal. So you ask the same question 4 times, you get 4 texts, and then you have to say, is that good or bad? And which is a very limited feedback, right? So if you go on a search engine like Google, then you have the page rank, which gives you some idea about how trustworthy a source is, because a lot of other sources link to it. And people have always tried to hack this, right, with link farms and stuff. But there's no real way of doing authoritative data sources in this sort of training process. That's something that needs to be cracked. So I think the next step will be, how do we actually build knowledge and concepts into these systems and refer back to authoritative sources? Obviously, you could have the idea that the system produces an answer, then does a search using that answer to find references, checks somehow what's the value of this reference based on other criteria, and maybe some sort of model it has in the background, and then validates its own output. And but things get harder because you have to put more effort in. It's more manual effort, more curation, and these systems that are currently built, the effort in data curation is very low. Otherwise, you couldn't do it.
And the recent release that is now coming is connecting for the first time to the internet. So ChatGPT will be connected to the internet.
Yeah, Bing already has done it. So when you use the new Bing and you get a chat result back, they build references in. Again, you actually need to check, because this is where these things can make stuff up.
I found, like, when you use Bing, the problem is like the new Bing with the Copilot or with ChatGPT built in. I found that the generative content is not so generative. Like it's really focusing on the 2-3 links that it finds as a relevant link, without doing the whole narrative creation power of ChatGPT, the real ChatGPT. So I think here we see a limitation. So I'm actually quite excited to see the real ChatGPT being connected to the internet. But do you think this is really hard to do? Like, is it like, for me, it sounds like, okay, you just read another few sources and you add that to the body of knowledge you have. But it might be not as easy, because, as you said, it's not understanding concepts. So maybe adding that in is less trivial than we would intuitively think as humans.
Yeah, it is difficult. What they probably do is they use embeddings to do document search. So if you can search in an embedding space, then you can use text similarity to find something. It also helps you to find paragraphs in a document that are related. And you could then use this and generate an output document by doing embedding search. So you do a kind of a combination of keyword search, then embedding search, then you combine it, and then you can throw this maybe into the chat engine, say, go over this and edit it a bit and make it sound nice. But this could be a way of generating responses which have genuine pieces of text from sources, which you can then reference. But it is then a multi-stage process, makes it more difficult to do.
And it might kill a little bit of the magic at the end, like in terms of the flow of the text.
Yeah, because you rely more on what's written in the original source. It's probably true,
Wow, yeah, so many things going on in that space, and every day you have stuff coming up, new apps. So I think we also see quite a shift. I think it's really a defining moment. I think in the economy, world economy, because I think there will be a new platform industry coming, an app industry coming out of it.
Yeah,
Do you see that as well?
I read there are already 300 apps that use ChatGPT as a backend, and the the problem is with this at the moment, at least. First, you can't rely on that the service is available. So if you build your business model on top of this, then you better make sure you have a fallback when they take ChatGPT away. And we have seen this already on GPT-2, the precursor of
Right.
ChatGPT. And so people have built stuff on top of it, and OpenAI is now taking this out of service. And so you're relying on a kind of an engine being available that may not be available in the future. And but yeah, obviously we'll see that, right? So you get all sorts of apps. The problem then again for the user is, do you know what's behind it? Can you trust it? So you wouldn't really want to use ChatGPT to ask for medical advice. But if you put a nice app on top, make it look professional, then suddenly it sounds like you're a doctor on an iPhone, right? And then again, this is a problem in terms of who do you make this available to? Is the user actually competent enough to understand that you're getting something that is potentially not right? And because there's no regulation in any form yet. So I just read today that the EU has agreed on the AI Act, and that they put something in to regulate foundation models. And this is currently, it's a completely open market. Anybody can do anything, but I would expect regulation to happen in this space. So you want to keep this in mind when you build your business model on top of it. Can you then take into account future regulation that might come?
Now, I think the interesting thing here is that through the internet, we had people publishing content every day. Billions of pieces of content is published every day on this planet. And some of it is really good content. Some of it is not so valuable, but it might be entertaining. But a lot of that content is misleading.
Yeah, that's true.
And that's human created content. Do you think we will get a higher standard for machines compared to human generated content?
It is.
Or will that affect both types of content?
Yeah, I mean, a lot of people say, why do we hold these things to such a high standard? Because you can't trust people, right? You don't know why, if people say the truth or make stuff up. That's correct, but there are slight differences. First, we relate to people in a completely different way, right? So we know what we are like. We are all the same in that sense, and so we have a kind of a good understanding how to take information that comes from people. We don't have this intuition when it comes to machines. In comparison to search engines, it's completely different because there's a lot of crap on the internet, but you probably won't find it. And so it's different to look for something in a search engine.
Or it's recommended as the next video on YouTube. I mean, or it's on a news website, okay. Which
it's true. But there's still a slight difference here. You have to now you have a kind of a model that has aggregated anything and can answer anything, and it does it in a very authoritative manner. So the intuition is what comes out of it is trustworthy and can be used. And if your people are more wised up to the fact that social media is a lot of stuff in there that's fake. If you search something on Google, you're more likely to find something that's sponsored by ads than not. And so the people have developed a way of working with these things. This is new. People need to learn how to work with it. And I'm not saying that this stuff should be kind of stopped or so, but there should be some disclaimers, right? So ChatGPT should say something like, I'm giving you an answer here, but please be aware that might be wrong, and you should check for yourself before you do anything significant with this answer. And people need to learn this. And then I'm sure these things can be really helpful.
So there was actually, I mean, since we're talking on this topic, there was this famous letter recently signed by a number of very prestigious AI researchers or leading AI researchers, and also some very leading figures, business people like Steve Wozniak and Elon Musk, and they really said like we should take a break essentially, and not continue developing for a while until we figure things out as humans, how to regulate, how to deal with that.
Yeah.
What is behind it? Why are these? I mean, those are people that I would say. I mean, they know what we're talking about. Both from a research point of view, but also there are people that simply understand economies very well and what might happen when they are concerned. I have to be honest, I start to be concerned as well. Why are they concerned? And do you agree with them?
Yeah, in some sense, yes. It's the if you make these things public, then you're doing an experiment on a global scale and kind of an unprecedented social experiment. And because there are no guardrails, essentially, I mean, okay, guardrails in the sense of that there's a moderation API around ChatGPT and they try their best not to produce toxic content. But the ChatGPT is not even the problem. The problem are the large language models that power this. If you use the API of this model, you don't have the moderation layer and you can get it to say whatever you want. That means you can use them to generate tons of fake content if you want. You can inject this into social networks. You can generate scripts for scam calls and all sorts of stuff. So that's the kind of concern that people have, that you can use them to mass distribute fake content. And we have seen what fake content in social media does, right? And now you have a way of industrializing that. And that's one of the main concerns. And the producers of these systems have a real responsibility here to prevent this, to make sure that they give access only, at least on a large scale, to the right people, that people learn that these systems produce sometimes wrong information. And there should be some way of marking output. This is machine generated, hasn't been checked, hasn't been written by anybody. So that's one concern. And people like Gary Marcus, for example, are very clear in saying that this is the main concern. These things are not reliable. People believe they are reliable, and they can also be weaponized to produce fake content en masse. And then you get the kind of worries that are a bit more out there, because again, probably not very responsibly, but you find that OpenAI talks about AGI, so artificial general intelligence, so makes noises like, GPT-4 is going towards kind of human intelligence, or becoming kind of, an AGI, an artificial general intelligence that can basically
taking steps towards singularity, basically. That's what they're saying.
They
is that
don't
right?
use that word yet, but that's what they say. And there's some people, especially around OpenAI, they seem to believe if you make these things bigger and bigger and bigger, and you throw more and more data in, at some point they actually become kind of artificial general intelligence. So they become human level intelligence and maybe sentient. And but most AI researchers don't believe that this is possible, because essentially what you do is you only train them on statistics on text. You're missing out a lot of concepts that are really relevant for intelligence, like having a world model, being able to do generalization, and to do concept understanding, these kind of things. So there's a lot still missing what you would expect an intelligence system to have. So I see it as very unlikely that these things will actually lead to an AGI. You would need completely different architectures. But what's true is that we need to start thinking about the AI control problem. So this is generally thinking around, if you have a very powerful AI system, how do you make sure it does what you want it to do and it doesn't misbehave, and the goals that are built into the system are aligned with our goals. And there's not enough research done in this space. And you don't need to think that far, that we're building a super intelligence that can escape the lab goes out into the world and then starts ruling the world. We don't even have to think that far. But there are people who are thinking that far. And it's essentially a philosophical problem to think about, if you build a super intelligence, what would this system do and how would we be able to control it? And so it's worth thinking about these things. In this letter, a few of these things got mixed up a bit. And so there's a bit of hype in the other direction, right? Overhyping the dangers.
The counter hype.
Counter hype, yeah. And
but the alignment problem is a problem. What I understood from listening to other AI researchers is that there's no mathematical definition of alignment. It's actually very tricky to define that and to give that as a requirement to a machine.
Yeah.
And the other very tricky bit is that there was some research done on GPT where they found out that it sometimes has agent-like behaviors, sort of working. And maybe it's not strong enough yet, but it shows like misbehaviors, you could say.
Yeah, I mean, these kind of behaviors are still explainable through statistics of language. But it is true in the sense, if you would say that ChatGPT should be a system that answers truthfully and kindly when you ask it a question, then they have failed in that sense, right? Because it doesn't always do that. And there's no way to make it do this reliably. So in that sense, we're already facing an AI control problem because we can't really constrain such a generic model in what it creates as an output. And so we definitely need to do work on this. And I mean, if people are interested, then Stuart Russell's book on this topic is a good idea. Or you have Max Tegmark has written Live 3.0 and addresses this topic. And there's the famous book from Nick Bostrom about superintelligence. It was already written in 2014. And
very visionary book because it really showed what is happening now.
Yeah, and essentially it's a philosophical discussion, right? So you imagine you can build a superintelligence, and it doesn't matter to know how you would do it, but you assume you can do it and it's there. And how do you set it goals? And then you very quickly find out that goal setting is not so easy. And then any system that has a goal will develop sub-goals. And so, for example, even if you tell the machine, bring me coffee, the machine will figure out, I shouldn't be switched off, because if I'm switched off, I can't bring the coffee. So you get, out of any kind of goal reasoning behavior, you get sub-goals, which may not be aligned with what you want. And even if you even try to formulate a goal, then you find out that can be misinterpreted. And there's this famous thought experiment of the paperclip maximizer. And so an intelligent system that has its only job is to build as many paperclips as possible. And because it doesn't know anything else, it hasn't been constrained, it then converts everything in the universe into paperclips. And because you forgot to tell it when it should stop, or that it shouldn't take humans and turn them into paperclips. And so a lot of things in terms of goal setting are very intuitive for us, but are kind of impossible to express in a formal language. And this is the kind of the alignment and control problem that needs to be solved. Stuart Russell has a kind of an interesting approach. He says it should be a bit uncertain about our goals and ask. The system should always have a level of uncertainty about what it should do. And if the level of uncertainty is too high, it should ask. That's an interesting thought.
And that's not happening at the moment.
No.
I never got a question back from ChatGPT.
No, it doesn't. It wouldn't know, right? It doesn't even understand that it produces falsehoods. It can't distinguish between truth and false because it doesn't have these concepts.
Right. No. It can only please, and getting by reinforcement learning, learn to please.
Yeah.
Wow, fascinating. Let's take a small pivot or a bigger pivot here, and let's look into what it means for businesses. Mm-hmm. You know, most corporations, there's lots of startups doing stuff in generative AI these days and creating apps, but also big corporates, most of them are starting to look into generative AI technologies and how to leverage them. How are you at BT approaching it? Why is it relevant? You told me in our previous discussion that this is really top of mind for a lot of for you as a business at BT at the moment. Why? Where do you see the potential? What do you see so valuable from a business point of view?
Well, we just have to look at it because it's currently so prominent, and there are lots of opportunities. So you could say everything that is difficult to create but easy to check is a good opportunity for these systems. And you can start with software engineering, right? So the plugins that you get for development environments like Microsoft Copilot or others, Amazon Code Whisperer, there are a number of these. And there you have a professional environment. You have people who can easily understand what the output of the system is and if it is valuable. And it can just help with kind of creating what you might call trivial content, like very simple code where you know how to do it. It's just a lot of typing and scaffolding code and simple functions where the system can generate this for you. And I see this just as the natural development of software engineering, right? So we used to use code libraries and maybe low-code environments. And the next step is generative environments that create the code for you based on prompts. They won't be able to do any kind of really sophisticated, intelligent programming because again, they can reproduce what they have seen, and there's a lot more simple stuff out there than specific stuff. And so you still need the software engineers to put it all together to make sure that the testing works. So orchestrating these kind of environments will be the job of the software engineer. They will learn new skills. They will learn how to prompt these things to get the code out that they need. And they will learn how to spot the weaknesses and the strengths of these systems. And hopefully it improves the reliability of code and the level of productivity. It remains to be seen. We're at the very beginning, but this is something that is relatively easy to try. Then you can look into copywriting, marketing materials, generating illustrations with these image generating networks. There you have to be mindful of copyright. And so you may have seen I've seen a demo of a system that generated an image, and in the background you had one of these watermarks from a stock photo company that was embedded in the picture. So clearly they have trained the system with the pictures that stock photo companies put on the front ends, right? They all have this watermark, so you can't do anything with it. But there are already lawsuits in the US from stock photo companies against these image generation networks around breach of copyright, or artists that have created images and the systems now learn to create images in the style of this artist. They are obviously upset about it because they haven't been paid for using their body of work for training. So you have to be mindful when you use these systems. You might get into some copyright argument. But then document search is another one. So if you have to work with complex documents, legal documents, technical documents, things like finding these documents, document summarization, asking questions about the document is all really helpful. And again, it's done as human in the loop systems where the people who get to see the output can make a decision, yep, that's correct or not correct. And that's what you need to do. Any use case should have human in the loop, people who can judge the quality of the output and then continue working with it. And then I think it can be really helpful.
And I don't think that all use case applications actually have that built in, a human control loop. So when I think about what the vision, at least, or the plan of Meta, the Facebook company, to actually create marketing content for you for Facebook and Instagram and so on automatically, develop campaign materials for you. That essentially, well, we have to see, but I'm wondering, how can you put so much human control for such an amount of content created every day. Probably you can only do that on samples or any other ways, or running some other algorithms to detect.
Yeah, I would be skeptical that you should let these things run automatically, and that you really know what it produces. But I mean, from the social network kind of operator perspective, for them, this generative AI is an opportunity to generate personalized content,
right?
And to tie you even more into these kind of systems. And that will go as far in the future that you get personalized video content that makes you stay in these environments and click on the next ad. And there the human in the loop goes out of the window, right? So I have no idea how they want to make sure that they don't generate inappropriate content or wrong content and expose that to people. That's pretty much an unsolved problem.
And where are you currently in your journey, leveraging generative AI?
At the beginning, I'd say. So we are just looking at what are use cases that make sense for us, and we are then kicking the tires on the kind of commercial offerings. Obviously, we have to use enterprise solutions. We can't use just ChatGPT, because that's true for everybody. Don't put anything confidential in ChatGPT, because the data may be used to train the next version of ChatGPT. And there have been articles already around Amazon and Samsung also have found out that there are people who put confidential stuff in there. Yeah.
And the commercials, yes, that was big in the news. And I guess the two major technologies that you can use for enterprises is really the Microsoft solutions on Copilot and Azure. On Azure, you can also use GPT Studio, I think, or OpenAI Studio, I think it's called. That's the major two options right now. Is that right?
Well, Amazon has Bedrock, which is a service you can use. Google is working on offerings. There will be a number of, so you can expect that all the large cloud vendors will have something.
And where do you see the current biggest challenges now, on the next steps to bringing the first things into production and use that?
I think it's time for reality check. What really works, what is financially viable, because remember, these things are expensive to run, and the vendors have to make money. And so at the moment it might be still cheap, but will it stay like this? The other thing is, can you train these systems with your own data, which is going to be one of the criteria to make it really useful. And so most use cases will not be on a ChatGPT level. They will be very specific to a domain, relying on corporate documents that you have. You need to be able to fine-tune these systems with these documents. Is this working in the API kind of offerings, or do you need to stand up your own large language model? Do you need to an open source one? I mean, Bloomberg has decided to build their own, right? And I think we will see this as well. Companies who build their own models, maybe an open source model, and refine it, or build something that is very specific to their use case.
My impression right now is that wow effect was created with data out there, so on the internet, data publicly available. I don't think we have seen a wow effect use case yet with your proprietary data. Maybe Bloomberg, but Bloomberg, as you said, was self-trained. That's a different story, because they put a lot of effort to train their own model.
Databricks released an open source model recently that they built themselves, and they kind of crowdsourced data from their own workforce. And so you would imagine that companies can do something like this, so get their own staff to produce relevant data and curate data. I think the real kind of path to success is well curated training data, to refine these systems or build them yourself from scratch.
And so one thing that, as you want to put things like that into production, one thing that is really top of mind is safety, security, and ethics.
Yeah.
How do you approach that? What practical advice would you give to other leaders,
Yeah,
that want
I
to
mean,
apply?
safety means to make sure that the models that you use cannot produce inappropriate responses. That means there has to be some sort of constraint around it. Then security means make sure they run in your own kind of space. So you need to use an enterprise solution. The data needs to be traveling there safely and securely, and it needs to be kept securely. The vendor should not have access to it or use it to build their own models. So that needs to be considered. Ethics is make sure that you know who you buy from. How have these models been built? Have they been built ethically? And what workforces have been used to build them? What data has gone into building them? That's something that we still need to get our heads around. So we have already the understanding that in like standard AI systems that are just for categorization, classification, prediction, we know data shouldn't be biased, data should be collected according to GDPR or other standards, and these kind of ethical understandings that the system should be fair and not discriminate. This translates into this world as well. And here you have the output side where you can have ethical issues, but also on the build side, because these systems are built in a completely different way, and they require much more effort and people to do this. We need to also look at the side, how it has been built. And if they use too much energy and compute, then again, it's another ethical problem. Do you really want to use something that uses a lot of energy and compute? Can you get away with something that is simpler and cheaper and more energy efficient?
How about the other ethical aspect? Like, for what kind of purpose you're using it for and how you're using that?
Yeah.
Don't we need also guardrails on that like if you start using that on a wider scale in the company, beyond POC, isn't that
absolutely.
something that will
This
become
is what I
critical?
meant, where we need AI regulation to kick in, right? So if these systems are open to the public, then we need to really think about what sort of guardrails do we need for this. So the most trivial thing would be disclaimers, right? So that people who use them know that the output might be wrong. And we need to rethink how should these systems be exposed to the public. This is not a question we had with the kind of previous generation of AI. In the use cases were mainly within a corporate space, and a company would have to think for themselves what is our ethical guardrails, how do we use AI, and how do we make that clear. Now this is a completely different scale. If you put something like this into an office like an office suite, office software, or into search engines, then you have a completely different type of AI proliferation, and you need to think, what are you doing with it? And this is on a society level. So this means where we need AI regulators to look into. And companies should restrain themselves, obviously. You would hope that the large tech companies that publish these things think safety first and money second.
Well, that might be true for some. So what kind of, you've done the first steps, you're screening stuff, you know your first use cases, you're screening technologies. What are the first lessons learned for you, in that process, in terms of the things that you could share with others, who are starting right now off on that journey?
Yes, I said
to use the technology commercially inside for in a large corporation.
Yeah, I mean, as I said, we're really at the very beginning. I can't report on any kind of success stories or cost. It's at the moment we are really looking into how do we do onboarding. What do we need to do in order to run this within a company? And it's just things around architecture, security, and what sort of ports do we need to open in the firewall, and essentially, and what sort of environments are appropriate for use. This is where we are at the moment. We don't have any experience around productivities. We have done kind of experiments where we see, okay, that looks promising, and we could imagine it will work. Like examples I said, software engineering, content generation for copywriting, and search of complex documents and summarization.
But how do you do the first steps to identify the right use cases, to test them, to see if they are valuable? How have you?
We run internal workshops with the commercial departments to see if we would give you access, what would you do with it? Kind of question,
right?
And what are the opportunities? And then you do some brainstorming around use cases, and you collect them all and you line them up. Okay, what's the most valuable one? What's easy to do? What can we do quickly and cheaply? So it's trying to find these use cases where you can actually execute very quickly, and you don't have to put a lot of stuff in place. And again, software engineering is an easy one because you just get a plugin for your development environment, and it's there. People can use it. If you want to go for a use case where you need to use your own documents, then you have to figure out how does the training of these models work with a document base, and that's something we haven't figured out yet.
So besides generative AI, what are other AI trends that we should watch out? You're working in AI research. That can't be the only thing that is currently going on in that area.
Before we all jumped on the generative AI train, was kind of the MLOps train, right? So the automation of machine learning in operation, and really having repeatable, reproducible templates for machine learning, so you can turn around use cases very quickly. And you have the data pipelines in place. You have the environments where your data scientists can very quickly stand up a model and push it into production, and making sure that this works in your environment. And again, doing this efficiently, and not necessarily encourage everybody to use deep networks, but try the logistic regression first, because that usually works, and then you can do something much quicker. And so it's building these kind of environments where you can build models very quickly, test them very quickly, push them in operation very quickly. So you have a kind of a CI/CD pipeline going, and that's where we learn from software engineering to replicate what happens in software engineering and bring this into MLOps, and to develop the right kind of architecture that works for your environment.
So let me close up here with the last topic, artificial general intelligence. How close are we to singularity? How close are we to artificial general intelligence?
Well, not close at all, I think. So that's going to take a while. And you get people like Stuart Russell say, I never say how far away we are, and I will not give you any numbers. That's generally not wise. But we are not really close, because the kind of systems that we are building here seem to miss very crucial kind of parts of what you would consider an intelligent system. Currently, you have to they don't work like we at all, right? They start always from nothing. You can't build any structures in that makes it easier to pick up a task. They don't do associations and generalizations. They don't understand concepts. They don't have a world model. So in order to do intelligent things efficiently, you need to develop a higher order expression of these things. So you need something like, let's say, second order logic. So you can train a system to play Go well. If you wanted to write this down as mini instructions, it is really inefficient. It's the whole system is basically filled with mini instructions how to play Go. If you could get the system to express this in higher level languages, build up representations, it would become more efficient, and it could do other things as well. And these kind of things we are not seeing right now. So I don't think we need to worry about AGI yet. What we need to worry about is powerful AI systems that are not efficiently controlled, and that essentially go rogue in their own way by producing toxic output, or do not exactly what you want them to do. And they be used in automated context where you then lose control. And
Right.
it's essentially automation that I would be worried about. Right? So, and automation can be done with very trivial software. So and you need to think about, if you automate something, what's the effect? What happens if it goes wrong? And now we have a way of automating stuff with statistical systems, which means they will always be a little bit wrong. And how do we control this? And we are now in this age of automating the creation of digital artifacts. Initially, that was only decisions like categorizations, predictions. Now we're going one step further and we are generating complex content like text and images. And this is where we need to think, if we do this in certain use cases, is this potentially harmful, and what sort of guardrails can we put around it? And then you can spin this out. You can say, okay, next thing might be we can generate code automatically. So can we change code in devices automatically? And then we affect the physical world. So if you have a system that generates code automatically and you use this to upload code into devices, which could be drones, could be autonomous cars, could be all sorts of devices that are controlled by small pieces of software, then you have an effect on the physical world. And then you can, or maybe you can create physical artifacts, like you can create drugs automatically, or you can create things through 3D printers. You could imagine you can print circuits now. So if you have AI systems that drive creation of these kind of things, then we get another step further. We need to think about how to control this. And if you then at some point get AI at creating AI, then you have kind of reached the ultimate level of automation. And then we need to be there. We need to know how to control these things.
We need to be careful.
That's why we need to look at.
We need beforehand to be careful before we do that.
Exactly. We need to have the methods to control these things.
Yeah.
And it doesn't need to be human level intelligent AI. Even kind of current level AI needs to be controlled. And that's why we should spend some effort in this space.
But what will happen when we reach that point where humans and machines will be on par, or maybe be less effective as humans will be less effective as machines when we really reach AGI or singularity? What do you think will happen to our society?
Well, this is what these people like Nick Bostrom or Stuart Russell or Max Tegmark are thinking through, right? So you can come up with scenarios, what might happen and how you want it to happen, how you would try and manage this. This is not really my area, but I think we should prepare for this journey, and that means we need to think about how we want to control this journey and how we want to control the things that we develop on this journey. So before you build it, think, can you control it? That should be the kind of thinking around these things. And that is even true for what you wouldn't call human level AI. But in terms of, we always had machines that can do stuff better than humans, right? A calculator is the simplest example. And you will have specialized machines who can do specialized things better than people. And as always in industrial revolution, some jobs will disappear, new jobs will appear, and society needs time to get to grips and manage these things. And then you go into the realm of politics. They need to get their head around how should this influence the change of society, and how should negative impacts be mitigated.
Which reminds me of a picture which just went viral of a Chinese nurse that was beating up a robot with a baseball bat. And I think that reminds me really of the Industrial Revolution, when people were destroying machines. So I think sometimes there are patterns in history that repeat. So maybe we can learn from them.
Yeah.
Well, great. Thank you, Detlef. This was such a wonderful, in-depth discussion on generative AI. And I think that is so valuable, because these days all social media, all media is full of noise. And it was really, for me, it was personally a great great experience to listen to your thoughts, since you're really spending so much time on that topic really professionally. Because it really cleared also some things up for me, and I'm sure also for a lot of the listeners, in terms of, what it actually means, what's behind it, how to leverage it, and what are the things we need to watch out and really putting a bit of an understanding behind that hype. So thank you so much for that.
Cool. My pleasure. Thanks for having me.
Borek Data Masterclass, where great data journeys begin.